in this section, we're going to start finding derivatives of trigonometric functions, and then we're going to take a look at some of the uses with regular old polynomial or algebraic functions, such as slope of tangent lines, product rule, quotient rule. So there are 6 trigonometric functions that are basic, and we can find the derivatives of those fairly easily. So I'm just going to write up the list. So the derivative of regular old sine of x, so d dx sine x, is equal to the cosine of x. The derivative of cosine of x is equal to negative sine of x. The derivative of tangent of x is equal to secant square of x. And then we have the cofunctions. So the derivative of secant is secant x tangent x. The derivative of cosecant x is negative cosecant x cotangent x. And then finally, the derivative of cotangent of x is negative cosecant square of x. All right, now we're going to go through these without any proof, although there are proofs using the limit definition. We're just going to avoid those. A trick that I learned a number of years ago to help with the derivative memorization is that take a look at any function that begins with the letter C. And what you'll notice is if the trig function begins with a C, it's negative. If it begins with any other letter, it's positive, at least for the 6 basic. Right? Now, if we start talking about some of the hypergeometric or the hyperbolic functions, or if we start talking about some of the arc functions, that's not necessarily true because those all begin with A, and some of them are negative. All right, so, but that might be a helpful hint for you guys if you're trying to memorize these. All right, so do try to memorize these as quickly as you can because it will be helpful for you to go through and doing these problems. So this is actually a fairly easy section because all we're going to do is just take these 6 definitions and we're going to apply them to all the rules that we already know about derivatives. So let's take a look at a couple examples of this. A really basic example to start. If a function is equal to negative cosine of x, what is the slope at 2 pi? Or in other words, what is f prime at 2 pi? So what we're going to do first is we're going to find the derivative of cosine of x. Now I'm just going to copy down the negative, and remember that because it begins with C, the derivative is negative, and the derivative of cosine is negative sine x, or in other words, that's just positive sine of x. Now what happens when we plug in 2 pi into the derivative? Well, that gives us sine of 2 pi, and on the unit circle, well, 2 pi is a complete revolution on the unit circle, which means we end up at the point 1, 0. Remember, sine is the y component, and so y is 0 at 2 pi, so this would be equal to 0. Another way you could do this is just cheat and throw it in your calculator if you're not too good with your analytical geometry. However, hopefully this helps you out to be able to figure out why that's equal to 0. So pretty easy. Another really example. This is asking us to find the second derivative of sine x plus cos x. And this is actually a fairly easy problem. So let's first of all find d dx of just sine x plus cos x. And that's going to be, we know the derivative of sine is going to be cosine of x. And we know that the derivative of cosine, because it begins with a c, is a minus sine x. All right, so that's our first derivative. For our second derivative, we're just going to take the derivative of the first derivative. So that's going to be derivative of cos x plus a negative, or just minus sine x. We know that because it begins with a c, its derivative is negative, so that's going to be minus sine x. And then the derivative of negative sine is going to be negative cosine. All right, it begins with an s, so the derivative of sine is positive, but the negative just kind of carries over. So this is going to be minus cos x. All right, so that's our second derivative of sine x plus cos x. Another way to write that is if you were to factor out the negative, you could write that as the opposite of sine x plus cos x, which is actually the original function that we looked at. All right, so not that you have to do that, but just illustrating that it does work like that. An example where we have to go through and perhaps use an old rule is we have this y equals 4 cos sine x. And this is where we're going to have to use the product rule. Now remember, our product rule is going to be that f prime or fg derivative is going to be equal to f prime g plus fg prime. And so in this case, f can be equal to 4 cosines of x, and g can be equal to sine x. Now we know the derivative of 4 cos is going to be negative 4 sine of x. All right, again, it starts with a c, so it's negative. And then the derivative of sine, which we're going to call g prime, is just cos x. And now what we can do is we could do f prime g, fg prime, and kind of smash those together. And so this is going to be negative 4 sine x times sine x plus 4 cos times cos. So cos x, cos x. Now be very careful here. We can write this as negative 4 sine square x plus 4 cos square x. And I know what some of you are probably thinking, oh, sine square plus cos square is 1. So if we were to factor out a 4, we would be left with negative sine square x plus cos square x. Now, this is not equal to 4 times 1 because of this negative. All right, so just be careful with that. Don't try to utilize the formulas for the trigonometric function or the trigonometric functions if they're not there. Okay, so we'll take a look at a few more examples involving trigonometric derivatives, but hopefully that's not too difficult for you all to understand so far.